Good morning, everyone. Welcome back. Today, we need to complete the review of data types for C. In particular, today I want to talk about arrays, and there is a very good reason for that. If you remember strings in Java, strings are going to become arrays of characters. So we're going to talk about it. So for arrays, number one, I assume that you're familiar with arrays in Java. Therefore, all these instructions here, those, you are familiar with them because they are the same that you use in Java for similar purposes. Like you can create an array with 3 elements and the array needs a type. And it's okay to create the array and also create some variables together in the same line. Did work. You can create an array with 1 dimension or 2 dimensions or more. Same syntax that you use with Java, the square brackets. Moreover, if you review this way of initializing an array, the same way work with Java and now with C, and it's going to work with C++. You can do something like this to initialize a 2D array. That is kind of a most complex scenario. And exactly the same apply to initialize a 1-dimensional array, a simple one. So you can put here the number, or you can use the empty brackets. And just because you provide 4 elements, the array is going to be size 4, the same that you have with Java. Now, accessing the elements, remember, the first element is 0, it's going to be the same. So if I have an array of 4, really, I can access my elements 0, 1, 2, and 3. And in order to access the elements, well, name of the array, square bracket, the index, and then I can put a value, and the value is going to be whatever that corresponds to the type of the array. The type of the array is really the type for each of the elements, and the elements are consecutive in the memory, same that you learn with the Java programming language. So what is new? The first thing that is new is this operator, CSE240, that we reviewed before. I mentioned operator. This guy is an operator like the plus, minus, multiplication, division, and others that you reviewed before. It's an operator, but it has a name, not a symbol. Yeah, but I want you to notice that there is no parenthesis there. You are not calling a method. It's the operator CSE240 and the name of the variable. Use like this, operator, variable, operator, variable. This one give you the negative value. This one is going to give you the size for the variable. Now, the size. If you're working with variables like this one or this one, they are arrays. The size is going to be something like this. If you're working with variables that are 2-dimensional arrays, the size is going to be something like this. And my question is, can you explain me why the size of A is 12 or B 16 or MA 24? Is the size of what?
The size of the integer times the elements.
Yeah. Do you remember? I think we reviewed this at the end of the previous lecture. Is A is 3 elements. Those 3 elements are integers. If the integers have 4 bytes, 3 times 4, 12. Probably B is going to be 4 elements, 4 times 4. And the tricky one, MA, if we look to MA, what is 2 times 3? I have a total of 6 elements, and each of them 4 bytes. Notice that for the arrays, the only size that you're getting with the CSE240 is the size of the data. This number or this number or this number do not include the pointers, the references that are connecting that data, particularly for 2D arrays. The size is only the size for the data, according with the type that you select. I am using for this example, this default int in 4 bytes. Remember, for the int, it's going to be depending on your computer. And I think we review 16 or 32 bits. I am going to use most of my example with this idea of 32 bits for the integer, therefore 4 bytes for the integer. And that means that the long is twice that size. Here, for the integer alone, what I am working, remember, with the modifiers is the short version of integer and obviously the signed version of integer. So these are the two modifiers. These are the two things that I am working in most of the examples, short and signed. And just because in the computer that I run the examples is 4 bytes, 32 bits, well, that is going to be the numbers. And I am pretty sure that most of you running any compiler locally in your computer or using the online one are going to get similar results. These integers in 4 bytes instead of 2 bytes. Good. So one very, very important case of arrays. I mean, in some point we're going to work with arrays and we're going to work with this short searching and sorting algorithms and so on, things that you already reviewed. But the first thing that I want to do is to talk about the relationship about arrays and strings. In Java, you have the class string. Here, there is no class string. There is no data type string. A string in C is going to be an array. And in particular, it's going to be an array of characters. That is going to be the data type that we are going to use for strings, like to store the name of a student. Remember that example? It's like there is no other way. With C, what we have is arrays of characters. That is going to be the equivalent to what you used before as the class string in Java. Now, yes, it's going to be an array. Yes, it's going to be an array of characters. But a lot of things that we use with the strings are going to be valid to be used with an array of strings. It's a very particular array. These two examples. I am sure that you agree that the first one is correct. The first one is something that you use in Java, you have a new array, and you can initialize the array with new values, and makes sense that if your array is an array of characters, then, well, you have one character, comma, another character, comma, another character, comma, and so on. Because it's the same that you could do with integers, an integer value, comma, an integer value, comma, and continue. That is fine. But also, if your array is an array of characters, you can do something like this. And that is quotation marks, a string inside, and each of these is going to go to one of the positions in the array. So you can use A or you can use B to create an array of characters and initialize, and both of them work. Obviously, I am pretty sure that when you create an array of characters, you are going to like this one more than this one. I mean, no commas, and you're going to save space for a lot of single quotes, right? The only thing that you need to remember is letter number 1, position 0, the next one, position 1, the next one, position 2, and so on. So that one for array of characters. Can we do this in Java in an array of characters? The second one, and hopefully you remember in Java, an array characters, you need to do the first one, not the second one. With C, you can do both, any of them. Now, one difference, one particular very important difference. If you use the first one, what you're going to have is an array with 1, 2, 3, 4, 5 elements, which makes sense, this array. And if you ask for the size of S1, the size of S1 is going to be 5. Makes sense. Everything is like, yeah, that is obvious. In the second scenario, you're going to have the same 5 character plus 1. \0, I am using the backslash used like with the enter and the tab and so on, but \0 is a escape character for the end of the string. Every single time that you initialize an array using something like this, you are telling the computer, this array is going to be for strings. And what the computer is going to do is to store all your data, and at the end, it's going to add one extra character. It's one character. Again, the representation is like \0, like \t or \n, just because that is the representation that we use, but it's one character. It's going to be 1 byte with information. And that one character represents, here the string is ending. This is the end of this string. So for this one, even though they are the same, because you use this initialization, if you ask for the size of S2, the size is 6. 6. All the 5 characters like before, plus 1 extra character, the end of a string. This is the only difference between doing this or this, working with arrays or moving forward and working with a char array using string notation. And there are going to be consequences for this. What is going to happen? Well, do you remember that we have this printf instruction? And for the printf instruction, do you remember that something that you put here is the format of the information that you want to print? So if I want to print S1, do you remember that one of the things that you can put here is an S? And that means that you want to print a string? Well, you can use this with S1, the variable that is an array, and you can print the string. You can print all the elements in the array with just one print. Just one. That is something that you cannot do in Java. If you have an array and you want to print the array, you need a for loop and print element by element. Here, only for the arrays of characters, because they are considered a string, if you use the %s and a variable that is a char array, all the information is going to be printed. The problem is, all the information is going to be printed. I am going to start with the position 0, move to the 2, 1, 2, 3, and so on. In which point I am going to stop? I am going to stop when I read the character \0. That is the reason because C add this character. Because when you work with the strings, and it's going to be working like if that was an array, it needs to know in which point the string ends. Where is the closing quotation mark. It's going to start with the 0, but how many characters do I have? Well, everything inside is my string until I read the end of a string character, the \0 that corresponds to closing the string. Yeah. So this is going to have consequences because every single time that you work with the strings, you need an array of characters. But every single time that you work with a string, that array of characters should have this end of a string character, one extra element. And this is something that we want to have. What could happen if, for any reason, I delete this character? What could happen if, for any reason, after doing something like this, char x equal high, an array of characters, high, how many elements? 3. Okay, x in the position 2 equal a new character. If I do this, h I \0, that is what I get from this line. If I change this for something else, I do not have the \0 anymore. So if I do something like this, print f, and I want to print a %s, a string, and that string is going to be x, as you mentioned in the chat, I do not have the end of the string anymore. What you're going to have on the screen is this instruction printing the element 0, the element 1, probably the next element, and another one, and another one, and another one. All of this, whatever you have in the memory in the next byte after that position. When you're working with the strings do not care about the size of the array. The string care only about the end of the string character. You need to be careful about keeping safe the end of a string character, because you can have crazy results if you lost that character. That character and this notation is the only thing that differentiates array of characters and strings for C. Examples, more. A program, and hopefully by now you're familiar with the language. Include a library, the library that have the instructions for printing and reading from the keyboard, hopefully easy. The main, this main, a big opportunity for ask a question. Do you remember that the main, we have two options. The main can be void and the main can return an integer. Do you remember that? Because in Java it's always public static void. In C, you can have, you don't care about the public, you don't care about the static, and you can have void or int. What happens if I do not put anything? Can I have something like this? I do not put void, I do not put int. Something that C has is this idea of defaults. Do you remember that we reviewed the defaults for the type modifiers? Well, you know what? For the data types, we also have defaults. Which one could be the data type by default? Int. So if I create a variable short int x, what happens if I only put short x, only the modifier without the type? Type by default, int. If you do not put a type in one place in which the computer needs a type, int. So in this case, you're going to check several examples in which people like me only put main, parentheses, and the brackets, just because it's quickly. When we do not put a type, the default, int, because integer, numbers, is the default for the C language. So you notice that I have the return 0, even though I do not have anything here. The default is integer. Now, I have this variable, and I want you to notice it's an array of characters. Hello. How many elements? If we ask for the size of S1, 5 or 6, maybe 7 or 4. Okay, 6, good. We have an array, and the array have hello and the backslash character. Always, 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 when you use the quotation marks, you're going to have the backslash character, the end of a string at the end. So in total, say 6 elements. Now, I can use this, and I can ask for printing the full array. And the result of that is this one. One print, %s. It's an array. It doesn't matter. All the elements are going to be printed, character by character until the end. Notice the end of a string character do not have a graphical representation. It's not printed. It's just the delimiter. The only thing that you're going to have on the screen is the characters that you put before that \0, which makes sense. These characters, and this is something that internally the computer is doing, but nothing that you are going to solve. Okay, now it's an array. Because it's an array, I can use a for loop, and the for loop can go from 0, the first element, to 5, the last element, one by one. And something that I can do is inside of the for loop, only one line inside of the for, so it's like curly bracket here and curly bracket here, right? Use one line inside of the for. I am going to print. I am going to print what? Notice that here I am using %c. I am going to print one character. One character? Yeah. In this array, the element in this position. Remember, it's an array. Name of the array, square bracket, the index, and that gives me access to one of these. And if I want to print one of those, it's a %c. If I want to print everything, it's a %s, string character. And if I have this for loop running with all these prints, notice here I print the string and the \n, I print an enter. So there is an enter here. But then here with the character, I am not printing the enter. So the for loop is going to print this letter, and this letter, and this letter, and this letter, and this letter. And it's going to stop because I ask for a loop to 5. So you're going to print 5 things. One print, one for loop with a print. The full string, character by character. In both ways, you can print the content of the array as an array or as a string. The only thing for this one, the \0 is important. And enter, whatever, and my program finished. Array of characters working as a replacement for your strings. Now, crazy things that could happen. And this is very, very common with C, guys. Anytime that you run a program and for any reason, like, professor, my program is working, but I don't know why, sometimes on the screen, there are like garbage. Bad news, guys, your program is not working. If in any moment you saw question marks, extra numbers, faces, happy, sad faces, anything that should not be there, your program have a problem. Particular, in this example, the library, the main, now explicitly integer, returning something, my array, hello, print as a string with an enter. That one is this one. So far, okay. The same example that before, but here, another error that I can make is, what if I have a for loop and the for loop go 0 to 20? My array is size 6. I am doing a for loop 0 to 20, and I am going to print the element 0, 1, 2, and so on until 19. What could happen in Java here between 17 and 18? Java is going to do something there, right? The virtual machine there give you this nice help, and yeah. Good news, bad news. Good news, you do not have exceptions in C. You can forget the index out of bound exception. In fact, you can forget the null exception. You can forget any of those errors. Your program is not going to show you errors. Bad news, your program is going to do something. Sometimes something crazy. Some people is going to miss deception, because at least with deception, I know that something is wrong, and then I go and fix that something. For others is, well, at least my program is working. It's showing garbage, but it's working. When you submit your homework, guys, if you start working with C after this class, just remember, the fact that your program compiled and maybe run one time do not mean that your program is correct. This is the first example, and there are going to be more. Anyway, so one thing that is going to happen with C, you have freedom. You can access the element 20 in an array, even though the array is size 6. No exceptions, no problem. You want the element 20? This is the element 20. The element 20 is, you ask for this memory is yours, but if you want the 20, well, the 20 is this one. It's not yours, but I can give you the information there. Full access to the resources, full access to the memory. That is what C and C++ is going to give you. And well, we do not know what is there. Maybe there are information, maybe there are garbage. Who knows? Another example, hopefully more interesting. What is this? Sharp include string.h. A library. A library for what? A library with methods that are going to help us to work with strings. There is a string library. Yes. Now, let's review some examples of what maybe we have there. Let's see. Number one. Hopefully we understand what is happening here. Nothing particularly new. Two arrays, we are giving information. Both of them are going to have the \0 because both of them are being initialized as strings. So far, good. A for loop, the for loop with only one line inside, 0 to 5 characters, one character, and then an enter. I think this one is easy. Character by character, printing the array. The only thing that I need to be careful is with this number. Do not put the 20 that we had before. Now, this is just to show you the array, but we can just do one line like this. And you can print, obviously, the %s. Notice that you can combine the %s with other elements in the string, elements in the string, %d, and the enter. All the things that you put in the string are going to be printed like s1 equal, but this %s is going to be replaced by the value of a variable. And then all this comma size equal is going to be printed, but this %d is going to be replaced by a particular value. Now, which values? Well, the first one, the %d, correspond with the s1. Therefore, the string that I want to print is s1. So this is s1. Continue. And then size of s1. Remember, this is an operator. The operator returns the size of the variable, in this case s1. I am going to check the size of s1, and it's going to be printing 6, including the \0 is there, is one more element, 6 elements. You know that something is a string when you print the size or when you access the size and notice that there is one extra element, and that one extra element should be the end of a string. Now, one line, printing everything. Another for loop, use similar to this one, character by character, the string 2, character by character, the string 2. Something that I want to ask you to review. In this library, you have some functions that you can use with the strings. In particular, those could be very useful for a homework that you are going to be doing. Can you guess, just with the names, what those functions are going to be doing? For instance, strcpy. Very good question. When you are going to call a method from the library, at this point, you are not going to have anything like something dot something. Because if you remember, the dot is the one that separates objects and methods, or classes and methods, the static methods. So far, we do not have classes, therefore, nothing here, and we do not need the dot yet. The only thing that we're going to use is the name of the method. For instance, these three methods, if we want to use them, it's going to be something like this: the name of the method that we have access because of the library, the parentheses, and here the parameters. First one, string copy. Copy. What is going to happen? You have one array, you have another one, and you want to copy one to the other. That could be the equivalent to having a for loop, and one by one, the elements, you are copying them. So instead of doing a for loop and copy element by yourselves, you can call this method. You pass two strings as a parameters, and basically you're going to copy one to the other. String copy. You call the method. You do not need to program the for loop. String compare. Do you remember the compare to method that you have with the strings? You remember the equals for sure to compare to strings, because remember, you cannot use the equal with the strings. You use the equal method. But there is also the compare to method. Remember? What was the goal of the compare to method with the strings? 0 is a method that returns 0 if the strings are the same, or 1, -1, depending of which one of the two strings was first in the dictionary, right? Compare to. The equivalent to the method in Java, compare to, is this string CMP. So again, strings, they are going to be compared, and this method is going to give you a 0 if they are the same, or 1 -1, depending of which one is first in the dictionary, alphabetically smaller or bigger. And string cat concatenation, to put two strings together. You can search for them, and I am sure you're going to find examples. We can review examples later, but this is going to be useful for your homework. Just remember the names. I need you to remember those names, the library, and particularly those three functions that we're going to be using later. Good. So this is handling the strings with C. Now, important. I want a variable, and I want to store in that variable the name of a student. What could be the way to create that variable? A variable for the name, a variable for the grade. The variable for the grade is going to be an integer, right? The variable for the name is going to be a char. Well, it's going to be a char, but it's going to be an array of chars. An array of chars for the name, maybe 10 elements. Char name, the 10, integer grade. Good. Now, these are my variables. The first thing that I do with a variable is put a value. I can put a value in grade like this, but it is more important to ask the user for the value. Which was the instruction that we need to use in order to ask the user for information? Printf to print in the screen. Ask for information from the keyboard. Scanf. Good. So scanf, parentheses. Obviously, you can use printf, and you can show a message. Whatever. But the important one is the scanf. Now, scanf for the grade, percentage. Percentage, which letter do I need to put there? It's an integer variable, so D, right? Not I, D. And the variable. The variable, unit grade. Tricky part. You need something there? Something for you to remember, guys. It's a common question in the exam and it's a common error. This line that I have here, just like that, is wrong. The scanf need two parameters. The first one is the format, yes, but the second one is not the name of the variable. The second parameter for the scanf is the address of the variable. And what we do to get the address? Well, we use another operator that we learned. The ampersand. The ampersand is an operator. That operator is not related with the ampersand that is the and. This one is a unary operator. The and is binary. You have two elements and the and is in the middle. This one is like the unary minus. This one is like the not. It's alone and it's at the beginning of something. The something is the name of the variable. Name of the variable, the operator ampersand at the beginning, and this one is going to give you the address. The address is the one that you pass to scan. So far, it's like, okay, makes sense. Nothing new. What about the name? Give me a name. Okay, so percentage something and something. Question for your exam. Tell me, which percentage do I need to use here? C, D, P, S. Okay, this was easy. Like you are asking for a name, the format is a string, so percentage S. You use percentage S not only to printing the data, but also when you want to get the data. The second parameter, the name of the variable. Okay, but we do not need the name of the variable. What we need is the address of the variable. Arrays are, by definition, addresses. You do not use the ampersand here when the variable is an array. So scanf, with everything, you need the ampersand. Scanf, if you are going to read a string, which is an array of characters, no ampersand, exactly, no ampersand when you are working with strings, arrays, no ampersand. Why? Well, something that we're going to review with pointers in the next lecture, but just to give you a global overview. My variable grade is the name for this box that could be 4 bytes. And this box have an address in the memory. When I use scanf, scanf need this number. That is the address of the first byte. That is what scanf need, the address, not the name. Now, no, you cannot do that. You cannot do variable equal scan because scan do not return anything. So the variable should be the second parameter, not outside with the equal. Make sense? Now, for the name, something that we are going to review, but this name is not the name of the array. This name is the name of this small variable here that is storing the address. of the first element in the array. If you take a picture of the memory of your computer, when you have a variable and when you have an array, this is a variable, use a box with a group of bytes there. When we have arrays, and this is something that you review in Java as references, this is your reference. The name of the array is really the name of this box that have the address of the data. So going back to Scanf, for Scanf, if I give grade, I need to use the ampersand grade because that is what I need to get this address of the first element. However, when I use Scanf with a string, with an array, if I give name, I do not need the address of name. I do not need this address because I do not want to store the data here in this box. I give name. Name is equivalent to whatever is inside of the box. And that one is already the address of the first element in which I am going to store the string. Again, this one is something that we're going to review in detail. My message right now regarding strings is if you use Scanf with any data type, you need this ampersand to get the address because the parameter should be the address in which you are going to store the data. When you are working with the strings, you do not need the ampersand. Never use the ampersand with the name of an array. Why? Because array, by default, they are already addresses. They are already this idea of references, pointers. No ampersand with the scanf and the name of an array. Make sense? Exactly. It's like, if you ask me, like, well, and what happened if use because I am a programmer and I forget this lecture and therefore I put an ampersand here. I am going to have some kind of exception? No, not really. My program is going to work? Probably it's going to work. In fact, you can tell me, Professor, I put the ampersand and my program is working. Yeah, I am pretty sure that your program is going to work. What is going to happen? Well, because you are using the ampersand, what you are going to pass to the scanf is going to be this address, whatever is the address. And whatever the user put on the keyboard, well, my name, in this memory. What is the problem with that? The problem is that, number one, I just replaced this data. So I do not have any more this reference to this data. All this become garbage. But the worst thing is I am using this byte, this byte, this byte, this byte, this byte, and they are not mine. What is going to be the consequence? Random. Exactly. You just corrupt someone else's memory. And guys, this is important. Consequences for this. Maybe nothing happened. I mean, maybe you are running your homework in your computer and you are not running any other program. Therefore, that memory probably is empty. No one else is using that memory. So you run your program in your computer and your computer is going to work like in the same way with the ampersand or without the ampersand. You are not going to notice the difference. You are corrupting the memory. But if you are not using anything in the memory, if your computer is only running your homework, or if you have a lot of memory and you are running 2 or 3 programs, maybe you do not notice that you are doing this. But maybe the TA is running like 20 of your homeworks at the same time, and also is listening to music, watching a video, doing another homework, it's going to crash in the computer of the TA. It's not going to crash in your computer. The program is correct? No, the program is not correct. This is an error. Good news, bad news. A program in C almost always is going to do something. Almost always is going to work, even if the program is wrong. It's not Java anymore. Yes, that is the conclusion here. Do not use the ampersand with arrays strings. Worst case scenario and the segmentation fault, we need to review this with pointers, but hopefully you remember you have the stack and you have the heap. You can do crazy things with the memory like this, and you are not going to receive an error. And when you receive a segmentation error, it's because you did something like this with a very long segment of the memory, or because you crashed something that was important. So maybe the operating system was working here and you just crashed the operating system, or a process that corresponds to the operating system. We need to talk about it, but you can do crazy things in the memory and nothing happened, nothing crashed. When the thing crashed, it's because something very, very bad happened. If you want to create a virus for your computer, if you want to do hacking, if you want to attack a computer system, the language that you use, C, C++. This is the language that you can use to have access to everything. And when you have access to everything, well, not always is because you want to do something good. This is just an error. This happens just because you forget the ampersand. But what if what I want to do is to forget the ampersand? That is an attack. I show you this example here with the 20. The only thing that I am doing is printing things, and I can print garbage. But what if I change the data in a position of the memory that is not mine? I am changing the data of another program running. Obviously, something like this is just randomly changing something. But if you can know what is running and what is the meaning of this information and what is the difference between a 0 or a 1 in that position, we are talking about different things. Attacking a particular function, action, stealing information, whatever. So things that you can do with C, but you are not going to do this. Good news, bad news. If you are using a fancy IDE, like if you are using Visual Studio, I am sure that a lot of these things, like this one, or like the ampersand, Visual Studio is going to be there, and Visual Studio is going to tell you, hey, wait, this is a problem. Yellow triangle or something like that, don't do this. Be sure about this, whatever. Visual Studio is using C, but it's using the C that corresponds to the .NET platform. So if you're using Visual Studio, somehow you have this nanny similar to the nanny that you have in Java. If you move forward and you use something more direct, like a C compiler in an environment like the console in your Mac or Linux, Unix system, you do not have that nanny, and therefore you can do things without anyone showing you these yellow triangles, whatever. If you have the Visual Studio, good. If you are working with the compiler online, probably you are not going to have these warnings. So you need to be careful with the numbers, and you need to be careful with the ampersand. That is the message. Yes and no. Segmentation foul. Something that we need to review is when you run a program, your program gets a space in the memory. That space is like my play area. And here I have my globals and my stack and blah, blah, blah. But then I have the heap. With the heap, I can use pointers. With pointers, I create objects and I create arrays. And something that we can do is I cannot access directly the memory of some other program running, but if I can create a pointer to this space, even though inside there is another program running, I can do things. But we need to review pointers. So arrays with the strings, a little bit about be careful with the ampersand and the memory. One last thing, constants. What do you do in order to create a constant in Java? Like if you remember this pi, if you want a value, what is a constant? It's a variable that you do not want to change the value. So what do you do in Java to create a constant? And yes, you have your keyword, final. Remember, hopefully you remember that. Well, the replacement for final in C, const. Const, yeah. So do we understand that one? Final, int, whatever, in C, const in the name equal a value, and you cannot change the value for that variable. If you try to do something like this, at least, good news, this is something that is going to be an error, compilation time. You try to do these two lines together, you're going to receive a message. The message is, sorry, but this cannot be done because the compiler is reading your program and the compiler noticed you have a const, and therefore you cannot use the variable in any place that imply an equal, an assignation. Final, const. Another way to define constants in C is this guy, sharp. We have sharp include for the import. We have sharp define. Define. This is the instruction and have two elements. Two elements. Number one, the name. Number two, values. Notice that the only difference is for this one I have a data type. For this one I am creating a variable. This one is just an equivalence between a group of characters and another group of characters. When I put something like this in my program, compilation time, something that the compiler is going to do is find and replace. The compiler is going to find this and is going to replace this one with the equivalence. Compilation time, the compiler is going to replace this thing with this thing. Replacement in compilation time. With this one, you are going to have a variable, a space in the memory with this particular value. In which cases you use define instead of const. With both, you can use you can use both with whatever data type, including arrays and later with classes and objects in C++. In which case you think define is better? Both work with globals and locals. There is only one case in which define is better. The big difference is with const, you have a variable. You have a space in the memory that represents a particular number of bits. You have the variable, you have the space, and you are not going to change the value for that variable never. with define, you never have that space in the memory, because what is happening is in compilation time, I am replacing this name for this number. So pi is not a variable. It's just a label for something that in compilation time is going to change. So maybe you want in your programs to use pi, and you put that define, and you define that pi, the equivalent is this. So the compiler is going to do this, find and replace all the occurrences of whatever you have here with whatever you put later. There is not going to be a type checking or whatever. It's just find and replace. But that is going to happen during compilation time. When your program runs, your program is not going to have in the memory a variable pi. So you have one less variable. You save a space of one variable, or you can save the space for more. It's about performance, it's about space. Usually, when we think about constants in Java, it's like, I want the variable, but the variable is not going to change the value. In C, it's like, well, if you're not going to change the value, why do you want the variable? It's not a variable if the variable do not change. At least for computer things, is you do not want the space in the memory. The only thing that you want is use one representation instead of the other in your source code. Define, const, you can check both. Define, usually when you want to increase the performance of your program, when you do not want to use more memory, that is your option. Any case, you can use const in the same way that you use const in Java. Both are available. Any questions so far? Usually, the only thing talking about globals and locals, obviously, when you have a program, you are going to have something like this. At the top, include your libraries. And if you use define, usually you're going to have them also together. There is a reason for the chart. You can do this, whatever. You do not need the semicolon. Then you can have a program like that. Method. Usually your main is the last one, not mandatory, but is common. And then inside of the main, you can put your program. Your program can have a constant x. Also, you can have a constant that is global. This here. Any difference is just the life of the variable. It's a variable, again, cannot change, but it's a variable. It's a space in the memory with an address and a value inside. This one is just a definition that this thing is equivalent to this thing. So I can use this one, for instance, in the main, in an instruction. A printf, and I can print a string, and I can do something like this. Compilation time, the compiler is the one that is going to search for all the occurrences of this, and is going to replace with the value that I have, whatever, an integer, a character, anything. So this at the top, this is global, this is local. the definition, the define, is not really global or local. It's just defining something equal to something, and you can use the first one instead of the second one. Obviously, usually the second one is biggest than the first one, and that is the reason because you define kind of a short version that then the compiler is going to replace, but your program is going to keep small. Something like this is going to look your program. Yes, something that is very, very common is, for instance, you can use the define to store an operation, and that operation can be here, but I need to review this together with the inline methods. So, but yes, you can use the define in order to define something that is more than just a value, something like, for instance, an operation. So instead of calling a method, you define an operation, and that operation is search and replace in your code. So it's like, instead of using methods, having all the code for something in a particular place. Yeah. But right now, my concern is for the variables. Be sure that you can use const or define for variables. Please go ahead and check the examples for this and this, and be sure that they run in your computer. Be sure that all of these examples, not only the constant, but mainly the strings, run, compile, and you understand what is happening. I am playing with this, but what happens if I have a full string hello world and you print the size, and then you print with the for, or you print with the %s? Be sure that you practice with this. Practice is the most important thing here. You can store commands, functions also, but that is a different story. We're going to review that with C++. Pointers to functions and function definition. Yeah. 2D char arrays, you can have 2D arrays of characters, yes. There is nothing that avoid that. You can have 2D arrays, 3D arrays with any type, including characters, but the only ones that are special, the only ones that have this end of a string, the only ones that you can use with these quotation marks is the one-dimensional arrays for chars. Those are the only ones special, and those are the only ones that replace the string. Unidimensional arrays of characters. Two-dimensional arrays of characters or two-dimensional arrays of any other thing, they work just like arrays. So for instance, very common question in your exam is like, okay, if I have a char and the char is X and I have 5 elements, I can do something like this. That is correct, right? So that means that if I have an integer Y and I have size 5, I can do 1, 2, 3, 4. B is correct. Can I do something like that?
No.
Okay, hopefully the answer is no. You want to create an integer array. Okay, it's Y. Okay, it's 5 elements, whatever. Okay, you want to initialize. You need the curly brackets. You need one number, comma, the other number, comma, the other number, comma, the other number, and so on. And closing curly brackets, semicolon. You cannot use this notation with other kind of arrays that is not the string. And the only one is the char one dimension. That's it. It's the only one that works in that way. And it's the only one that is going to add the /0 at the end automatically. That's it. Good? Any question? Okay, guys, see you next lecture, and we are going to review pointers, the most important topic. Good? Take a look to the slides. See you.